x1 is the topological space, and phi of x1 we consider here, that is this, only this part. If we take phi of x1, just we mentioning in the schematic structure here, only this part of this region we take phi of x1, and here it is an open cover, and this open cover already we take here for phi of x1, and now another function, that is we take here this open cover. Simply that's a covering systems to cover whole of the sections, and now we are taking here another quantity like g alpha, that will be the part of intersection here. If we consider here like this type of element called g alpha, that is intersecting element of phi x1 as well as j alpha. J alpha will consider as an open cover and index sets, where J alpha is open cover and it is open in x2 tau 2 for each alpha belongs to cup index set. Now by the property of continuity phi, we have phi inverse of J alpha is open in x1. It's clear. If we take here phi, then correspondingly we are get back here, and if we take here phi inverse, it is easily seen, and this phi inverse, that is we are getting back here phi inverse of, that is the quantity we find here, and get back this type of result, phi inverse of G alpha. We take it here, that is also open in x1. And now for each alpha belongs to cup, so we have phi of x1 is equal to union of alpha belongs to cup G alpha, and that will be is the subset of alpha belongs to cup J alpha. So by the property of continuity we have x1, that is phi inverse of this. It is clear. Continuity property already we discussed in homeomorphic and continuity property, and then we are getting back here phi inverse of this. This is a subspace, and if we take this result, it is x1 and it is equals to this actually, and this is the subspace of this. And if we taking the summation sign there outside the function, we are taking this result. So it is clear that it is totally covered up by these systems. Now phi inverse of G alpha forms an open cover for x1. It is clear that's an open cover, and as x1 tau 1 is a Lindelòff we already considered, so there is a countable open subcover for x1. Say x1 is equal to phi inverse of j1 union phi inverse of j2 up to phi inverse of j1 up to infinite extent. So easily we can find phi of x1, that will be union of n equals to 1 to up to infinity jn, because if we taking the summation overall step, that is union of phi inverse of j alpha 1 in this way, if we making a step clearly, that is whole step is converted like this. x1 is equal to summation n equals to 1 to up to infinity phi inverse of jn, and if we take in this way phi inverse of union n equals to 1 to up to infinity jn, if we making in this type of state, then easily it clear that phi of x1, that will be this result. Clear. It is from here n equals to 1 to up to infinity jn phi inverse of, and in this way, and thus phi of x1 is equal to phi of x1 intersection of this, and if we take this result summation convention n equals to 1 to up to infinity phi x1 intersection jn, and that is clearly gn we consider here this result, and so gn becomes a countable subfamily of G alpha belongs to cup index set to cover phi of x1, and hence phi of x1 is Lindelòff subspace of x2 tau 2. It is a clear result. Now we end our discussion today. If you like this video, like it, share it, and don't forget to subscribe the channel. Thanks for watching.